Hey, alright, are we ready for our first video? Good day, I think is what I'm going to have to say, since some of you are going to be seeing this in the morning and some of you are going to be seeing it in the afternoon. So, I'm making these ahead of time for now. It is August 22nd, and it is hotter than something that's very hot. How about that? So I'm going to try and make this as quick as possible without rushing so that I can turn my super loud fan back on. So we're going to do 2.1. Generally, I'm going to have some notes written out for you ahead of time. So pause me now and copy this down, and then we will discuss. All right. So mathematician notation is going to use as little writing as humanly possible because mathematicians are lazy. There's literally like one parentheses difference, if I remember correctly, from, or maybe two. I think it's only one. Doesn't matter. Anyways, this is the notation that mathematicians use for simply adding two polynomials, or adding two functions, excuse me. Oftentimes they're polynomials, but not always. Subtracting, this is the notation we use, and this is what it means. What you need to be sure to do is, if g of x is a polynomial, you need to make sure you distribute that negative to all of the terms of g of x. So this is a good note-taking strategy, especially since you have me on a video. Pause me and make a note of the note that I just made. Get it? They're called notes. Okay, sorry. All right, so distributing the negative to all the terms in there. Multiplying, this is just simply multiplying f of x times g of x. Oftentimes will foil to binomials and things like that. And then dividing, this is the notation we use, and this is all that it means as long as g of x is not equal to 0, because we don't want to have an undefined function here, okay? All right, so how to find domain. You're going to be doing some problems involving these. I'm not doing examples of everything because this is much review. So, excuse me. Domain. If we have a fraction in our problem and we're asked to find the domain, the denominator must be non-zero. Okay, so if our problem looks like this, we have a fraction with a numerator and a denominator. To find the domain, we set the denominator not equal to 0, and then we solve for x. If we have a radical and we're asked to find the domain, the root index is even. The radicand must be greater than or equal to 0. The radicand is the thing under the radical. So I want you to take a second and think about, if this is odd, what would happen? What would be like the rule for finding the domain? So pause me for a sec. Okay, so first I'm going to talk about even, and then I'll talk about odd. So for even, I can take the square root of 1 and 2 and 3 and 4 and 5. Some of those I would need a calculator for. I can take the square root of decimals and fractions, 1.4 for example. Again, I would need a calculator. I can even take the square root of 0, hence the reason we have an equal sign there. 0 times 0 equals 0, which means that the square root of 0 equals 0. But I can't take the square root of negatives in the real number system. Unless we say otherwise, we're always in the real number system. There's one chapter where we focus on imaginary numbers this year, just like last year. Odd, can I take the cube root of -1? Is there a number times itself that equals -1? Yeah, -1. Right? -1 times -1 times -1 equals -1. So that's why we focus on only even root index. And again, this would be a nice spot to pause and write like root index if you want to remember some terminology. Okay? So if I'm given a function that looks like this, the radicand is under the root, square root, or whatever the root is. To find the domain, we set that radicand greater than or equal to 0 and then solve for x. Okay, so let's look at an example. Back up a second. Notice here we're saying what x cannot equal, and here we're saying what x can equal, right? So I'm going to show you in a minute we need to state what x can equal, and I'm going to show you how to do that on this type of problem. So we're looking at that right now. Excuse me. So I'm going to follow my directions, set the denominator not equal to 0. And then something that people always forget, and it's pretty early in the school year, so I'm not going to hold you to it, is taking out a common factor. But we did review factoring, right, earlier. This feels weird to say that because it's August 22nd and we haven't started, but when you're watching this, that will be true. Now I want you to continue factoring, and I'm going to give you a question on that. Okay, so hopefully you got this, okay, and that means that x cannot equal 0 from this, x cannot equal -2 from this, and x cannot equal 2 from this. So now I need to know, how do I get what x can equal, okay? So if I eliminate 0, -2, and 2, I'm saying I want to have x be everything else except those. So I suggest you draw a number line. This is not required if you can get this without the number line, but oftentimes people leave pieces out if they don't draw a number line. Be sure to put your numbers in order. It sounds silly, but oftentimes people make the mistake on that. Uh-oh. There we go. Okay. So I'm putting those on my number line. I want to exclude those values, right? X cannot equal those, but I want to include everything else. Okay, so we're going to use interval notation. This portion to the left of -2 goes to -infinity, and then it goes at -2 and it stops. I'm not including -2, so I need a parenthesis. Remember, the bracket means it's included. Together with union, I'm not including -2, and then I'm going all the way up to 0, and I'm not including 0. Together with, or union, I'm going to go not including 0, and I'm going to include everything in between 0 and 2, and then I'm going to not include 2, and I'm going to go everything to infinity. This is the answer to the question. I want to know what x does equal, not what x does not equal. Okay? So, last thing with 2 examples. I'm hoping that my video doesn't stop recording because I seem to have memory problems on the video. All right, I call this the in quotes, and I'll explain why in a minute. The difference quotient. This is going to be hugely important in calculus. There are many difference quotient. Difference quotient just means a quotient, so division, with a difference, so subtraction. This is the one that is a huge definition in calculus. That's why I put the and then I did it in quotes. So we're going to practice this so that when you get into calculus, or when we get into calculus later in the year, you've got the background needed. I know you can't see. This is the pitfall of being a lefty. So you can pause me. Okay, so pause me if you need more time to write that down. What I suggest is finding this part of the difference quotient separate from everything else. F of x plus h. Okay? So if I asked you to find f of 4, what would you do? You would plug 4 in for x, right? If I asked you to find f of 2, what would you do? And hopefully you're taking the time to answer these questions as I'm asking them. Normally in class, I would have you guys actually answering them. I don't remember what I said. F of 4, f of 2, right? We plug those numbers in for x. So what I'm doing here is I'm taking the x plus h and plugging it in for x. So I'm going to have an x plus h in here, and then everything around it stays the same. Okay, so I just replace the x with an x plus h. Simplify that, and then move on. Okay, so this would be another great place to take notes on your notes. Start by finding f of x plus h separate from the difference quotient. So finding f of x plus h and simplifying it. Then we're going to write the difference quotient. like to color code my notes as much as possible. Okay, that's the difference quotient. So I'm going to take this f of x plus h. I'm going to subtract the f of x, and I'm going to divide it by h. I'm just applying this formula right here, okay? So what's the next thing that I'm going to need to do to simplify this? All right, hopefully you said distribute the negative. And then notice this is going to happen most often, almost exclusively. Anything that doesn't have an h is going to cancel out. It's not always going to happen, but it's going to happen most often. Because then what happens is the h can be reduced with division and multiplication, right? And we end up with an answer like that. Okay, one more of these. So just like I said before, we're going to start by finding f of x plus h separate from this big ugly fraction just to make our lives a little bit easier. So I'm going to take that, let me color code it like I did before. I'm going to take that fraction exactly the way it is, but instead of having x squared, I'm replacing this x with x plus h. Okay, so it's exactly the same fraction, but I've replaced x with x plus h. I'm going to simplify that by foiling. Okay, I'm foiling that out. X plus h times x plus h. If you need to write that out, that's totally fine. There ain't no shame in that game. Okay, x plus h times x plus h, and then foiling. Now I'm going to go back to the difference quotient. Whoopsie. Go back to the difference quotient and start plugging stuff in. Okay, so this is my f of x plus h. Minus f of x, minus the original guy, all over h. F of x plus h minus f of x all over h. And I do have to simplify that, so this is another Algebra 2 trig thing, okay? This is going to be something that I'm going to try and beat into your heads as much as possible without being violent. I want you to get rid of fractions. I do not want you to give these a common denominator and combine them. That is going to make your life miserable, and it's going to lead you or open you up for making more mistakes than what I'm about to show you. Okay, so I want you to look at all of the fractions within the fraction. So I've got this orange guy, I've got this purple guy, and I've got this purple and pink guy. What is the least common denominator of those three fractions? I need an x squared and an x squared plus 2xh plus h squared. Okay, I'm going to multiply top and bottom by the LCD. I don't need to write the 1 because that's just wasting my ink, okay? I'm going to multiply the top and bottom of the big fraction by the LCD.